Hello everyone, my name is Lakshman. I am pursuing my degree in the CSC department of SBCE College, Bangalore. Today I am here to explain a PowerPoint presentation on CPU scheduling architecture in the operating system. In the first slide, let us see the introduction. In this presentation, we will be learning about the CPU scheduling algorithms in the operating systems. These algorithms are very important topic in operating systems. This is because this CPU scheduling algorithms forms a base and foundation for the operating system subject. There are many processes which are going on in the operating system. A task is a group of processes. Every task is executed by the operating system. The operating system divides the task into many processes. The final goal of the operating system is completion of the task. In this slide, let us see the overview of CPU scheduling. The CPU scheduling is the process by which a process is executed by the use of resources of the CPU. The process can also wait due to the absence or unavailability of the resources. These processes make the complete use of central processing unit, that is the CPU. The operating system must choose one of the processes in the list of ready to launch processes whenever the CPU gets idle. A temporary CPU scheduler does the selection. The scheduler chooses one of the ready-to-start memory processes to get the CPU. Before going to the types of CPU scheduling algorithms, we are going to learn about the basic terminologies which are allowed and is used in the CPU scheduling algorithms by us. In this slide, let us see some of the terminologies used in CPU scheduling. The first one is the process ID. The process ID is the first thing to be written while solving the problem. The process ID acts like the name of the process. It is usually represented with numbers or P letter with numbers. For example, 0, 1, 2, 3 or P0, P1, P2, P3 and so on. The next one is the arrival time, the time which is required for the process to enter the ready queue or the time when the process is ready to be executed by the CPU. This arrival time can be represented as AT in short form. The arrival times is always positive or also 0. Burst time. The time slot which the process requires to complete the process is known as the burst time. The burst time can be represented as BT in short form. The burst times of a process is always greater than 0. The next one, completion time. The total time required by the CPU to complete the process is known as completion time. The completion time can be represented as CT in short form. The completion will always be greater than 0. Turnaround time. The time taken by the CPU since the process has been ready to execute or since the process is in ready queue is known as turnaround time. The turnaround time can be calculated with the help of completion time and arrival time. The turnaround time can be represented as TAT in short form. The turnaround time is the difference of completion time and arrival time. As we can see in this formula, TAT is the turnaround time, CT is the completion time, and AT is the arrival time. Waiting time, the time the process has been waiting to complete its process since the assignment of process for completion is known as waiting time. The waiting time can be represented as WT in short form. The waiting time can be calculated with the help of turnaround time and burst time. The waiting time is the difference between turnaround time and burst time, and the formula is WT is equal to TAT minus BT. TAT is the turnaround time and BT is the burst time. In this slide, let us see some of the types of modes in CPU scheduling. The modes in CPU scheduling algorithms are preemptive approach and non-preemptive approach. Preemptive approach, the process once starts its execution, then the CPU is allotted to the same process until the completion of process. There would be no shift of processes by the central processing unit CPU. The complete CPU is allocated to the process and there would be no change of CPU allocation until the process is complete. The next one, non-preemptive approach. The process once starts its execution, then the CPU is not allotted to the same process until the completion of process. There is a shift of processes by the CPU. The complete CPU is allocated to the process when only certain required conditions are achieved, and there will be change of CPU allocation if there is break or false occurrence in the required conditions. Now in this slide, let us come to the main topic of this presentation, the types of CPU scheduling algorithms. The first one is the first come first serve scheduling algorithm. This is the first type of CPU scheduling algorithms. Here in this CPU scheduling algorithm, we are going to learn how CPU is going to allot resources to the certain process. Here, in the first come first serve CPU scheduling algorithm, the CPU allots the resources to the process in a certain order. The order is serial way. The CPU is allotted to the process in which it has occurred. We can also say that first comes first serve CPU scheduling algorithm follows first in first out in ready queue. The second one is the shortest job first CPU scheduling algorithm. The shortest job is heavily dependent on the burst times. Every CPU scheduling algorithm is basically dependent on the arrival times. Here, in this shortest jobs first CPU scheduling algorithm, the CPU allots its resources to the process which is in ready queue and the process which has least burst time. If we face a condition where two processes are present in the ready queue and their burst times are same, we can choose any process for execution. In actual operating systems, if we face the same problem, then sequential allocation of resources takes place. The third one is priority CPU scheduling. This is another type of CPU scheduling algorithms. Here, in this CPU scheduling algorithm, we are going to learn how CPU is going to allot resources to the certain process. The priority CPU scheduling is different from the remaining CPU scheduling algorithms. Here, each and every process has a certain priority number. There are two types of priority values. Highest number is considered as highest priority value. Lowest number is considered as lowest priority value. Round robin CPU scheduling. Round robin is a CPU scheduling mechanism. Those cycles around assigning each task a specific time slot. It is the first come first served CPU scheduling technique with preemptive mode. The round cabin CPU algorithm frequently emphasizes the time sharing method. We have reached the end of the presentation, guys. Hope you liked my presentation on the explanation of CPU scheduling algorithms concept in the operating systems. Let us meet in the next presentation. Thank you.